And really, this is the second step of simplifying, because when we get to something like this and we see the parentheses, we've got to get rid of parentheses before we can box up terms and really simplify anything. We have to distribute. So when we looked at this and talked about the distributive property, if I was going to pass out papers and say, okay, distribute these papers to the class, that means give one to everybody. And it's really the same concept in math. We have to give one, give it to everything inside the give the number on the outside to everything inside the parentheses. So here's really what this means. If I have 2x plus 3, that really means that I have 2 x's and 3 positive chips. This 2 here really means that I have this picture twice. So that means I have the same thing one more time. So if I look at this, I really have 4 x's and 6 positive chips, or 6. Okay, well, how can I get that with these numbers? Well, if you think about this, look inside those parentheses and think boxes. I want you to think in terms of boxes here. Well, I really have a 2x and I have a 3 inside of there, if I were to kind of think in terms of boxes here. And I need to distribute that 2 to all the terms inside those parentheses. So 2 times the 2x gives me 4x, and 2 times the positive 3 gave me the 6. And that matches with the picture. I have 4 x's and I have 6 chips. This picture, on the other hand, on the bottom would look like this. If I've got 2 negative x's, I can just draw them like that, and I have 5 negative chips. 1, 2, 3, 4, 5. And the 3 on the outside says, okay, I have this picture 3 times. 2 negative x's, and 1, 2, 3, 4, 5, and I have this one more time. Because I have this negative x's, and I have this 3 times. Okay, so, oh, come back here, negative x. Come back. Okay, so when I look at that, well, how many x's do I really have? I have 2, 4, 6, and I have 15 negative chips. Well, that's really what's going on here. Is if I were to think about the terms that are inside of those parentheses, and I distribute that 3 times the negative 2x's, if I have 3 negative 2x's, I'm going to have negative 6x. 3 times the negative 2 gives me negative 6. And 3 times a negative 5 gives me negative 15, or negative 15 chips. And I can write that like that. So negative 6x minus the 15, and that works. Okay, so we did some examples here in notes, and we went over these and said, okay, if I have, come on, change on my screen. I'm glad that you see it. Okay, so if I were to do this, come on, hold on a second. I lost connection with my iPad. Okay, so as I'm going and doing these, and these were ones that we kind of did together in class, we tried them a little bit. Here's how this looks. So the first thing you want to do is you want to think in terms of, okay, how many terms, how many boxes would I have inside of those parentheses for each one? So we really went through and we said, okay, I have an x and a 4y. I have a negative m and I have a 2. I have a negative 4x, a negative 8y, and a 3. I have a 3m. Okay, so that's really the first step, as we went through and we boxed up everything that was in our parentheses. And then we said, okay, now we can go through and we can distribute. So the negative 2 times the x gave me a negative 2x, and negative 2 times the 4y gave me the negative 8y. So you could write it plus a negative 8y, or you could just simplify it and write it this way without having to write 2 symbols instead of 1. They're the exact same thing. For number 2, 5 times the negative n gave me the negative 5m, because that's really a negative 1m. So 5 times the negative 1m gave me the negative 5m. 5 times the 2 gave me a positive 10. 7 times the negative 4x gives me negative 28x. 7 times the negative 8x gives me negative 56y, so that's where that's coming from, a negative 56y, and 7 times the 3 gives me a positive 21. Then I've got number 4, negative 9 here. That's a negative 9. Negative 9 times 3 gives me the negative 27. Negative 9 times this gives me a negative 18m squared. And negative 9 times a negative 4 gives me a positive 36. And that's why we use those boxes to catch that negative 4. Now for number 5, this one looks a little bit different than the other examples. So we talked about if you have 2 times 3 and 3 times 2, does the order really matter? No, it doesn't. It wouldn't matter if the 10 is in front or if the 10 is behind. We still have to distribute that 10. So 10 times the negative 6 would be negative 60, and 10 times the x gives me the negative 10x. It wouldn't matter really. We talked about with these ones with terms, if they're rearranged a little bit, it really doesn't make a difference either. Like this could be 10x minus the 60 or plus the negative 60 is the same thing as what this is here. It doesn't matter if the boxes are rearranged a little bit. Now, these examples were different. This one is not in your notes. So we said, okay, watch out, there's a trap right here. This is a trap because order of operation says I have to multiply before I can add. Okay, so the trap is what most people look at this and do and go really fast to go, oh, that's a 10, and then you distribute the 10. Nope, that's not the case. We have to multiply here first. There's a multiplication here first for that parentheses. Okay, so we have to actually distribute here first. So that's a positive 3, to keep that in mind. Positive 3 times an x is a 3x. Positive 3 times, if we're to do boxes in here, that's a negative 2. 3 times a negative 2 is a negative 6. Okay, and then we can kind of drop down that positive 7 there. And now we can go through, now that the parentheses are gone, now we can go through, do our boxes, and simplify anything that we need to. Well, 7 and the negative 6, 7 and a negative 6 gives me a positive 1. Again. Oh no, I need to rewrite. Excuse me. Hang on a second. Oh, and it came back. So that was a positive 1, and then I had the 3x left over, so I can just, so it's 3x plus 1 or 1 plus 3x was the same thing. Okay, now this one was in your notes, and this one is where you've got to be very, very careful about that. Okay, so this one was the one that was in your notes, and this is one where you got to be very careful. This one looks different, and again, there's a trap built into the front, but you got to watch out. That's really a negative 3 that we have to distribute. So if we're looking at our terms here, this is going to end up different than the one that we just did. So a negative 3 times an x is a negative 3x. A negative 3 times the negative 2 gives me a positive 6. That's the key. Negative 3 times a negative 2 is a positive 6, and then we can take that 7 and put that down there. So now when I do my boxes, I end up with 7 and a positive 6 give me 13 and a negative 3x, or this could be written negative 3x plus a 13 because it's positive. Both of these are the exact same thing. They're just rearranged a little bit. Okay, so this is completely different than the other one. We got to watch out for what we're distributing and look at the symbol right before it to say, okay, is that a positive or is that a negative that I need to distribute? Because if the 7 wasn't there at all, that would be a negative 3 that we're distributing. So that's why that would be that negative 3. So these are the two examples that are a little bit different that you got to watch out for. So that's an example on how to distribute again if you need a little bit more review from what we did in class.